$100.
Do you agree with that?
Annual cost?
Yeah.
Yes.
Yours is about that?
Well, I guess I don't know, but I mean, like, it feels about right, like, about spending about $14,000 on a child per year. Although probably not accurate anymore, this book was made in the, like, whatever, 8 years ago. There's been inflation since then, but anyway. In a random, I didn't mean to capitalize that, in a random sample of husband-wife families in the U.S., the mean annual cost of raising a child age 2 and under is $13,725. Okay, so this is what the sample showed. The sample showed 13,725. And the researcher claimed that it was 13,900. So I'm going to write H sub O, H sub A. Okay, what's the claim? Yeah, but like, what should I write?
H of O equals 13.
Mu
Oh, mu, sorry.
equals 13,900. 900. This is the sample over here. This is their claim right there. In this case, the null is the claim because it's equal to. Opposite of that is 13,900. How are we doing so far? Everybody with me? Okay. What kind of test? Oh, and it also says the population standard deviation. That sigma is 2,345. This time we're using a level of significance of 10%. We're willing to make a 10% error. Now, if I'm claiming that it is 13,900, was it? No. So is the answer automatically, no, it's not 13,900, so we're done? No, because there's like a window of, okay, if it's between this and this, then we're going to assume that maybe you're right. So now the question is, what's that window?
Would that make it a 2?
It's a two-tailed, yes. This is a two-tailed test. Do you guys see why yesterday we did a lot of homework on, hey, just write the null and alternative. Is it left, right, or two-tailed? Just to get you used to it. So now this is a two-tailed test. We're going to have two rejection regions.
So that would be 0.5 on each.
Good, yes. Alpha is 10%, which means I'm willing to make a 5% error over here and a 5% error over there. Now, we actually already did this, right? We have found, everybody look up. We've found right here that if there's 5% on the left, that's negative 1.645. So I'm going to write that one in right now. This one is negative 1.645. Tegan?
So what's the alpha thing? Because why wouldn't it be, if we're willing to make a 10% error, why wouldn't it
Be 10%? Because these two add up to 10%.
So wasn't the last one different?
No, the last one was 5%, but it was only a left-tailed test. So, right, this rejection region by itself is 5%, where on this problem, it's a two-tailed test, so these two rejection regions together are 10%. I'm willing to make a 5% error over here and a 5% error over here. Yep?
So would that mean you would have to do 2 equations?
No. We're still going to see where it goes, but over here is going to be positive 1.645. Because if they're trying to claim that the average cost of raising a child is $13,900, then if it turns out, look, it's actually $20,000 to raise a child, then they're super wrong this way. But if instead it's like it's only $6,000 to raise a child, then they're super wrong this way. So there's actually two ways to fail now. They could either be our sample could be way too low or way too high. Or it could be somewhere in the middle, which is would prove their claim. So now we're going to do the test statistic. That's x bar minus mu over sigma divided by the square root of n. X bar is 13,725 minus, what do I use for mu?
13,900.
13,900, whatever that claim is, divided by 2,345 divided by the square root of
500.
What did you say?
500.
Yes.
Negative 1.60.
what did you say, negative 1
6, 7. That's wrong.
No, I'm not saying you're wrong, I'm just, this is in the book. No, wait, yes it is, I wrote down the problem wrong, so we've got a different problem. 13,725 minus 13,900. Do you love when people close the door and think we can't hear them?
Other people in here.
Yeah, I got negative 1.672. Also, not 2. So I got z equals negative 1.67. You guys getting the same thing?
Yeah.
Okay, so where'd we fall?
In the rejection.
We fell into the just barely, right? We just barely fell into this rejection region over here. So that means that we're going to reject what?
Everything.
Reject, so I'm going to write I reject. The first thing you think about is the null. I reject the null. Yes, because, and so look over here, look up. I'm going to immediately cross this one out because I'm rejecting it. I like this one instead, and I rejected the null and and the claim. I reject the null and the claim that the average cost of raising a child the average annual cost of raising a child is $13,900. Okay, how are we feeling about this so far?
Amazing.
Not bad? This is the second way to do this, which we're also learning today, is very similar, except for instead of comparing z-scores, you're going to compare a percent to alpha. Okay,
The alpha's the
level of significance,
cancer ridden.
the error we're willing to have, yeah?
Can you go back to that page for 6?
Here.
It was pooped on air.
All right, now we're going to move on
This is. I think that
to the second half,
and he's making the outside world look like his tank.
using p-values to complete a hypothesis test. This is not rejection regions, this is p-values or comparing percents. You're going to find that a lot of this is extremely similar, which is good, because you kind of understand the first stuff already. Ryan, are you still with me today? Yeah? Okay. You're looking over there like you're disappointed at our fish.
Who's gonna lose it?
I was kind of just staring. I don't know what I was looking at.
That's all right. All right, here we go. Step 1. Verify.
Is that bracelet new?
It's a hair tie.
Oh, okay. I was gonna say, normally you don't wear a bracelet.
Normally I have my hair up.
That is true.
Verify that sigma is known and that it is normal or n is greater than or equal to 30. This is exactly the same step as in the problem. Next step, write the null and alternative hypothesis.